You know nothing. Okay, great. Hi, Harold. How are you?
Hello, can you hear me?
I'm very good. Where are you calling us from today?
Perfect. I'm currently in Germany, my home country, finally back after a long road trip
Amazing.
past Sub-Zero in Lisbon, which was a great event again, and then a company retreat, and now finally back home.
Amazing.
Yeah.
Well, I guess I'll turn it over to you at this point. Um, just to clarify things, I think we'll do the presentation first, and then we'll maybe address some questions at the end. And yeah, I guess with that, let's see if you can share your screen.
Okay, sounds good.
Yeah,
I'm
all
I'm
good.
Let's go. I'm Harald from Zeitgeist, and this presentation is called Calling to the Zeitgeist Core Protocol. We are currently experiencing a workshop within the ecosystem, Encode Club ecosystem. And before I go into the presentation, I think I want to maintain a little kind of habit and start it off with a little beatbox sessions. As always, completely freestyled and crafted for the given context in real time. This is Encode Club. Okay, now we can start, I guess.
That's amazing. Thank you for doing that. That's the best thing I've seen all day.
Cool, great. It means a lot to me. Thank you. Happy if I could bring a little smile on your faces. Now let's get into the rough part. So what we'll talk about today is general blockchain architecture, like how, from a very high level perspective, how is a substrate blockchain designed. And following that, we'll move into shedding light on how to interact with part of the blockchain, the runtime, using Inc. After that, I'll give you a little insight on the Zeitgeist Protocol. And the last one should have been an example to call into the Zeitgeist runtime. At this point, unfortunately, bad news. This won't be the example, but we still call a runtime and interact with the runtime using the call runtime feature. Finishing off, we'll have some time for questions and answers. So what we see here is a very high level perspective of the blockchain architecture. So I think the easiest distinction you can do from a design perspective is to say your substrate node consists of a client, which is the big box on the left side, and a runtime, which is the green box on the right side. And the client can call into the runtime using runtime call executor. So the client is like the very foundation of the substrate node. It is what ensures proper operation on the lowest technical layers. For example, it ensures that all the substrate nodes find each other, can communicate with each other, and exchange messages. It ensures that all the data is actually stored physically in a well manner. It ensures to provide remote procedure call interfaces to the outside world, so you can interact with the node, and yeah, much more. So it just ensures the foundation is set. And so then there's the runtime, the green box on the right side, which is compiled into WebAssembly, and thus it is portable. It is portable to any operating system because it is it's interpreted instead of compiled, in contrast to the client, which is not easily portable. You have to compile it for every architecture you want to run it on. And the runtime is what actually contains the logic of the blockchain, the business logic. So what is it actually doing? It's transferring funds from A to B. It's providing some NFTs. It's allowing you to deploy smart contracts. Stuff like this is all handled in the runtime, and it can be invoked through the client by the client to the runtime call executor. So we have like a very simple perspective of the runtime. It's also called business logic, which is quite an obvious term from my perspective because it maps like what the chain's purpose actually is. And I also like to call it state transition logic because all it basically does is, if you further abstract it, you have like some kind of state. For example, Alice has 5 ZTG, Bob has 10 ZTG, and then it provides a set of rules that can be invoked with given parameters to change this storage from a previous state to the next state. For example, Alice transfers 1 ZTG to Bob. Now, storage before would be 5 Alice, 10 Bob. Storage after would be 4 Alice, 11 Bob. Yeah. So that would be one example. So basically, that's what the runtime is doing, just modifying the storage according to some rules on a very abstract level. The runtime itself is what we see here is the runtime again, but it's just like a bit zoomed into the runtime. The runtime itself, it is consisting of many components, and one of the central components of a runtime are the runtime modules that you see in the middle. Those are actually also called pallets, and this is what contains the state transition logic or the business logic that we just talked about. Below the runtime modules, you can see some examples. For example, you have the frame system module is one runtime module and provides the very lowest level of primitives and everything for the other pallets to work properly, like what is an account, what is a block number, and such things. And then you have on the right side the frame support library, which gives you like useful types and traits, so you can easily get on and quickly get on actually implementing your custom business logic without being bothered with that kind of stuff. And so frame system and frame support play kind of special roles in the palette or runtime module universe. And besides that, anything else could be around a palette, any other business logic, like palette balances, for example, that handles how to transfer balances and how to reserve them or lock them, or palette contracts that's actually handling the ink contracts and ensuring every component of the blockchain is communicating properly to execute this ink contracts. So going up from the runtime modules, basically through the executive palette, they can call into the runtime and interact with each other. So it's basically orchestrates all the pallets within the runtime. Let me take a sip of my water while all of that information is settling. So what we see here is like also a very high level perspective from Inc. So in the middle, the white box here, you can see our blockchain, the substrate blockchain, the thing that we just saw, that was talked about. And one of the pallets, one of the business logic modules within the runtime is pallet contracts. And pallet contracts provides an API that can be invoked by WebAssembly code to execute certain operations on the storage or execute certain units of logic. For example, on the right side, get a storage element, set a storage element, get a random number, transfer, and there's like the basic set, like a defined API for this kind of interactions that pallet contract exposes. And on the upper side, you could see contracts that are written in Inc, for example, in Solidity or Ask Assembly script, and they will eventually, when you wrote the text, like when you wrote the code in text form, it will be compiled to WebAssembly bytecode. WebAssembly is operating system independent, as we said, because it's an interpreted language, and that bytecode can then invoke the API from pallet contracts that we just talked about to execute operations on the blockchain, like transferring funds. Now, there are the classic way of developing smart contracts is that you think of your smart contract as an encapsulated unit of logic that is also capable to invoking other contracts to extend its own functionality. So you would have contract-to-contract interaction. Now, Inc and the substrate architecture allows you to even extend that further. And I like this funneling image here. Probably was not meant exactly like that, but you basically, you can see Inc as the very top layer on the blockchain. You can still write Encode, write encapsulated smart contracts that do some kind of things like create a token that can be transferred within the storage of the smart contract, or you can whatever you are used to already with Solidity, for example. But in addition to that, Inc is also capable of calling into the pallets, into like the business logic of the substrate blockchain itself. And even more impressive is that it is also capable to, if the parachain is configured properly, it is also capable to interact with other blockchains and other ecosystems via XCM. XCM is cross consensus message protocol. To basically, it's just messaging formats, so different chains can use to communicate with each other. So it does not mean like transferring the information, it's just a message format. So how does the message look like? Okay, didn't want to go into that details much, but in a nutshell, with Inc, you have the power now to call native runtimes of a blockchain, and you even have the power to call into other parachains and potentially other ecosystems as well. So you could, for example, if everything is configured properly, you could, for example, invoke a balance transfer of DOT from the Zeitgeist parachain if certain conditions are given. And or if Ethereum would implement the XCM standard at some point in the smart contract, you could even interact with Ethereum from Zeitgeist, for example. So that's a very powerful concept, and it basically opens the gate to interoperability. And I like the picture here because you can see it flows like information at some point can flow out of the parachain into kind of cave. And at the exit there are many of other exits of the caves where you can come out and flow into another funnel again. So there's like big opportunity to work on interoperability with the features that Ink provides. So how can you actually do that would be, I think, a logical question to ask after that. And Ink provides you with two concepts that you can utilize to interact with the parachain runtime, and also, if provided by the chain, with other ecosystems through XCM. So there is one concept called chain extensions. And basically this means that your parachain runtime, and this is the parachain runtime is the yellow bubble, the orange bubble here. And the teal intersection to the purple bubble, which is Ink. The teal intersection is like a common set of APIs and interfaces that is changed by the runtime in Ink. So your palette could, for example, let's assume you have the balance palette. It's a pretty intuitive palette to use as an example. Let's assume you have a palette balance palette. You can define interfaces in the balance palette like get balance or set balance or get reserves, get logs, or force a transfer, whatever. You can define interfaces for that as a trait, as a Rust trait, and implement them in a balance palette. And Ink has the ability to, on the other side, to also implement these traits and then call into the runtime using those interfaces and interact with the palettes through these interfaces. So, for example, Ink could tell palette balances if it would have a chain extension for sending tokens or for getting a token amount to send a token amount or get a token amount. So this is very powerful. So basically, the runtime can expose any kind of functionality or storage or information to the Ink contract, but it has to be maintained. So somebody has to provide that logic in the first place, and then it has to also to be maintained. And it's actually the most powerful way of interacting with the runtime, because you can essentially do anything. You get all the information about errors. You can query the storage from palettes. You can even deal with weights if that's what you need. And yeah, I think I forgot something, but can't remember now. So this is actually, if you want to do it in a clean way, you probably provide chain extensions for your palette or runtime. But there's also another way, which is much simpler and requires less maintenance. And this is the call runtime feature. So you can see both of the bubbles, they have been torn apart now. Parachain runtime and Ink smart contract do not share a common intersection anymore. That's because there are no interfaces, no traits, no APIs that are shared. And the way call runtime works is every palette has already dispatchable calls that you can call by sending transactions to the chain. For example, palette balances has the transfer dispatchable call that you can invoke by signing a transaction and sending it to the blockchain network. And all of those dispatchable calls, they are also available. If configured that way, they're potentially also available for Ink to be used. So as a side note, palette contract has to be configured to allow that, but it's basically possible out of the box to just use this dispatchable calls without any further effort. So it's pretty easy way to get started. No effort involved, no maintenance involved. on the pallet side, but it has some drawbacks. You cannot retrieve information from the pallet or the runtime using this. You can basically, that's why there's only one error and no intersection. You can basically just call the runtime, but you never actually retrieve any data from the storage. You cannot retrieve the errors, as far as I know by now. You cannot retrieve the errors, and probably one of the biggest arguments to not use that kind of mechanism is that it's not backward. It's not basically using call runtime forces the pallet to always, to all eternity, maintain the calls that are invoked. So you cannot change the interface of the pallet anymore in regards to the dispatchable calls. You always have to provide the backwards compatibility, and this would be like a big argument to not go with their approach, but can get started with it pretty quickly and easily. So a couple of words to Zeitgeist Protocol. So Zeitgeist is a prediction market platform. One of the main uses of that is to aggregate information from the crowd to precisely predict the future outcome. So anybody could create, in this platform, anybody can create a market, a prediction market, and a prediction market consists of a question and several outcomes. For example, in football match A, will team B or team C win? So you have the outcomes team B and team C, and those can be traded by the informants, and the price, the sum of all prices will always map to 1, which can then be mapped to a probability distribution. So for example, team A price could be 0.8, team B price could be 0.2. That would mean there's an 80% chance, based on the information the informants provided, that team A will win, and there's a 20% chance that team B will win. Without going into further detail, there's the prediction markets palette that basically provides the functionality to create those markets, to transit the states of those markets, to resolve those markets, to redeem the rewards. There is the swaps palette, which allows you to exchange outcomes in several different ways. There is the asset manager that manages all the tokens, foreign tokens from other chains, outcome tokens, Zeitgeist tokens, anything. There is everything I'm listing here, by the way, that those are all single palettes. There's a dispute mechanism in case the reported outcome after the market closed is regarded or seen as incorrect by some participants. And within the disputes, there are several mechanisms that can be used. All of those are single palette as well. Authorized is an authority says what the outcome was. Curd is a decentralized curd, like a digital curd with different euros. And global disputes like a last resort mechanism where all token holders can actually vote on what they think the truth is. And yeah, we have also other palettes like the order book palette, which provide you a classic order book to serve supply and demand for the outcomes. And there are many, many more palettes. It's actually a lot more palettes. You can see a link down below. If you want to see all the palettes, you can click on that. It will show you all the palettes. But for that presentation, it's not relevant. And I would also like to reduce the palettes I want to talk about further to prediction markets, swaps, and asset manager. If you want to accept and approach the hackathon challenge that we post, then those are the palettes you most likely will be interacting with and calling into. So you will either create or manage markets using prediction markets. You will maybe provide some new means of trading against the markets. And yeah, you might want to like provide new mechanisms to exchange tokens, like outcome tokens or something. And those are the three pellets that you would have to keep pay attention to if you want to create a solution for the hackathon. Won't go into further detail here, but if you have any questions in regards to what the functions, any of the functions of those pellets, on how to interact with them or something, then feel free to leave me a message. You can do it in the Encode Club Discord. There's a specific section for that. So I think it was 30 minutes plus 50 minutes, right? For Q&A. I have like a live example of deploying a contract that invokes a runtime call, but if there's no time for that, we can skip that, and maybe I'll provide a post-mortem or something that describes how you do that. Okay, I guess we go into Q&A, and if there's time in the end, we'll do the workshop anyways. So here's a link to the slides, and also the Zeitgeist page where you can find any relevant information in regards to Discord, social media, and so on.
Yeah.
Thanks,
Thank
everybody.
Thank you so much for that, Harald. I just want to say that if you don't get the slides here, I'll make sure, I think Yasin's going to make sure to post them on the Discord channel later on. As Mark said, yeah, let's do questions, guys. So let's see, come on. Has anyone got anything that they want to ask about? I guess as people are figuring out what they want to ask. Harald, how long have you been working at Zeitgeist?
I've started at Zeitgeist in April 2021, yes. So about around 2.5 years now. Been quite a great journey.
Okay, fun. How are you finding it?
It's a great experience. So we have like a very very open and trustful culture within the team, and also with our community. And I'm really enjoying that, like to be in that environment. So it's definitely one of the best team experience I had so far.
Amazing. I guess we've gotten some questions coming in. So Mork has asked if you could maybe elaborate on where XCM ties into Ink, Palette, and Zeitgeist.
Do you mean how you would configure a blockchain or a runtime so Ink can invoke the palette? And I have no idea. I think it's not been done yet. I have not done it, so I cannot answer it. But I know it's technically possible, and I think this would be subject of a whole other presentation and workshop, probably even multiple, because it's more complex thematic. But sorry, I cannot answer that on the spot here. But we can have discussions about that.
Why don't we go to the next question that Mork has asked about the dispatchable call trait?
Yes, give me a sec. Maybe I have the example at hand where I can show it actually. So yeah, here's an example. There's also a link in the slides. Here's an Ink example called call runtime. You can utilize this project to create your first call runtime contract that basically just allows you to call into the balance palette to transfer balances. Where is it? So I'm wondering if you mean this kind of things, because we have two enums here. One is called runtime call, which basically maps maps a palette to an enum element, and we have the enum balances call, which actually maps to a specific dispatchable call within that palette. Is that what you were referring to?
So he's asking, it was something that you mentioned, yeah.
Okay. So we have here's the substrate repository. This is the new substrate repository that contains substrate, and there's, for example, the balances palette. So if you open a ballot has a very specific structure, and within that palette you can first see like an overarching module called palette most of the time, which has the frame support palette attribute, and within that module, you'll just have to search for palette call, palette double, like, I think I'll increase the size a bit. You have to search for this palette call, and within this, all the dispatchable calls are listed. So those are the calls that can be invoked via transactions and also via the call runtime feature via Inc. And for example, you have transfer allow def, set balance deprecated, and so on. Those are all dispatchable calls that can be invoked via transactions or the Inc runtime call feature. Now, assuming you would want to send the transfer allow def, assuming you want to call that dispatchable call, what you would have to do is to look up that index, which is usually specified as call index. If that's not the case, it's the position within all the dispatchable calls. So this would be 0, 1. And you specify this in your call enum within the Inc contract, like this. So we can see it specifies the dispatchable call index 0. And if you go to palette balances, you could see this is what this transfer allow def is. The methods are under the palette call attribute are the only functions that you can call through Inc using the runtime call feature. If you want to have further access to the palette, for example, if you want to read data, you have to rely on the palette providing proper chain extensions for that. It is not possible to interact with the other functions using runtime calls.
Okay. Are there any other questions, or Mark, do you want to follow up on that? Did you just address this, the methods other than in the balances palette that you could use to runtime call from, right?
I think maybe I just partially addressed it. I think so. If you want to go beyond the balances palette, the same rule applies all the time. The only functions that you can invoke are the ones that are under the palette attribute call. Only those can be called using runtime calls. And this is true for any palette that is in the runtime. But with one constraint, palette contracts has to be configured to allow invoking those calls. So technically, out of the box, you can invoke any dispatchable call in any palette, but the palette contracts within the given runtime has to be configured in a way to allow that as well.
Okay, I can see that there's some typing happening. Yeah, there's definitely a lot of information to take in there, but glad to hear your question was answered.
Yeah, hope this helps. I have maybe one more thing that I'd like to mention, or maybe show, if there's no other question.
Yeah, go ahead.
Maybe you have another question in the meantime, but until this happens, one more thing is when you I opened the call runtime example crate here, and one thing that I've just talked about is specifying the dispatchable call index in the enum call, but you also have to figure out the palette index for that specific call. And the palette index, it's maybe interesting to see the one time. The palette index can be, let me quickly open the link. The palette index can be retrieved in the runtime configuration. So here we have the Zeitgeist runtime, for example, and there you have the construct runtime macro. And within the construct runtime macro, all the palettes are listed. All the palettes that the runtime provides are listed. And you can also see an index here. Like in this case, in our case, palette balances will have the index 10, for example. So usually the clean way is that it's explicitly specified. If there are no numbers specified like that, you just number them incrementally based on their position on which they are defined.
All right, I don't know if you saw, but we got one more question in the chat from Simon. He's asked, how may I validate that the palette is corrected, integrated to my solution?
I don't think I understand the question yet. Do you want to know if the interaction with the palette using runtime call? Is the question if how to know if that was successful or not? Or please elaborate.
All right, I'll give Simon a second to clarify.
No, that's the thing. With call runtime, you're basically left standing alone in the rain. You just shout out, "I want to call this," and that's it. No more information is provided, except if the call failed, you will know that, but you will don't know why it failed. You will don't know if any events were emitted. You will just know if it was successful or not. No more information. So for anything else, if you want to have events, if you want to have errors, if you want to maybe retrieve other data, you will have to rely on chain extensions. Runtime call will not be able to serve that need.
All right, well, Simon, I hope that answers your question. Maybe you can confirm in the chat. Thanks. Okay, it looks like we're all good. We've got a little bit of time left, so if anyone wants to squeeze in a last question, please do so now. But if not, I'd like to say thank you to Harald in the meantime. You've run a very helpful session. Big thanks again for both the educational content and then the entertainment content. Love the beatboxing to start. Yeah, it looks like we've already got some thank yous. Yeah, I saw in the chat earlier that a lot of people thought your presentation was very clear, very fun. So thank you so much for coming today.
Thanks a lot. Appreciate everyone and the opportunity to being here. Had a lot of fun hacking your solutions. And yeah, feel free to reach out to me anytime.
Okay. Well, good luck with the rest of the Polkadot Hackathon, guys. Yeah, just keep doing what you're doing. Happy building.
Thanks, Astrid. Bye, everyone.
Bye.